Hi, I'm Karthik. I'm studying in President College Shimoga, second year CS branch. Now I'm going to explain about functional units of computers.
Let us start with the block diagram. A computer consists of five functionally independent main parts: input, memory, arithmetic and logic, output and control units. Now you can see this diagram. Here these are input and this is output. Then we have memory, arithmetic and logic and control. These are the main five parts of the computer. And the central block, there is the interconnection network. It is used for the flow of information. So it will be whenever these different functional units want to communicate with each other, it will be through this interconnection network. The input will accept the information from the outside with the help of say input devices such as keyboard, and then the information will be stored in the memory and it will be processed by the arithmetic and logic unit. The control unit will coordinate these all activities. And when the processing is done, the output unit will give the output to the outside world. So these are the overview of the computer hardware. Let us go into details. The the input unit accepts coded information from human operators using devices such as keyboard or from other computer over digital communication lines. So here the input unit will accept coded information from human operators. So coded means when we use the input device such as keyboard, we'll get the information will be sent in the form of ASCII codes. Because your keyboard is ASCII keyboard and the code of each key will be fed to the input unit. Then other devices are also used for input such as mouse or touchpad or other things are used, and here it may also get from other computers, that means in the form of digital communication lines, that is information we can get through the internet. Then the information received is stored in the computer's memory either for later use or to be processed immediately by the arithmetic and logic unit. So here the computer memory will store the information and it is processed by the ALU maybe immediately or it can be processed as at a later time. Now the processing steps are specified by a program that is also stored in the memory. So the program or software will specify the steps for processing the information. And finally, the results are sent back to the outside world to the output unit. The output unit can be anything like printer or any output device. Then all these actions are coordinated by the control unit. So control unit will is the main unit which will control all these actions. And the interconnection unit provides the means for functional unit to exchange information and coordinate their actions. Then let us go further. We'll discuss the input unit now. So computers accept coded information through input units. So most common we have discussed is the keyboard. So whenever key is pressed, corresponding letter or digit is automatically translated into its corresponding binary code and transmitted to the processor. So generally this letter, that is nothing but the alphabet, or the digit is numbers 0 to 9, or any other characters which are possible with the keyboard. So we'll have the ASCII keyboard is generally used, and it will have a binary code which we call it as the ASCII code, and that is transmitted to the processor. Then many other kind of input devices are available, including the touchpad, mouse, joystick, and trackball. The touchpad generally is used in the laptops. Mouse is a common input device. The joystick and trackball, these are the input devices which are used in the video games. So these are often used as a graphic input devices in conjunction with the displays. So we have these devices with the displays, that means the screens. Then microphones can be used to capture audio input, which is then sampled and converted into digital codes for storage and processing. So you can give input through the microphone. The microphone can be connected with the help of the connector, and directly you can give the input to the computer. Now this will be converted to digital codes with the help of analog to digital converter, and then it will be stored and processed. And similarly, nowadays digital cameras, webcam, or other types of cameras, they can capture the video input. So they will be used with the computer. Then digital communication facilities such as internet can also provide input to the computer from other computers and database servers. So directly you can get the input from the other computers or databases servers to internet. Then next we'll go to the primary memory. The primary memory is also called as the main memory, and is a fast memory that operates at electronic speeds. Programs must be stored in this memory while they are being executed. So generally the programs which we want to execute will be stored in the primary memory. The memory consists of large number of semiconductor storage cells, each capable of storing 1 bit information. These cells are rarely used or written individually. Instead, they are handled in a group of fixed sizes called words. So here we have group of fixed size that is called as words, and generally memory is organized. One word can be stored or retrieved in the basic operation. So number of word length will be generally 8, 16, 32 or 64 bits depending on the operating system and the processor. Then HA memory. Now this is an adjunct to the main memory, a smaller, faster RAM unit. It is called as cache, and is to hold the sections of program that are currently being executed. So along with its data. So cache is tightly coupled with the processor and is contained on the same integrated circuit chip. So the cache memory is generally part of the CPU, or the processor. It will be put along with the chip itself. So we call it as the on-chip cache. The purpose of cache is to facilitate high instruction execution rates. So here the speed of execution of instruction is important. That's why the more cache on the processor, the better is the performance. Then the start program of execution, if the cache is empty, then whenever the data is required, it is stored in the main memory. But as execution proceeds, we can page the processor chip and copy each of place in the cache memory. So when the execution of an instruction requires data located in the main memory, the data are paged and copies are also placed in the cache. Then the next is the secondary storage. Now this secondary storage, it is a primary memory, it is the memory which is additional than the primary memory. Because primary memory, the cost is high, and that's why it tends to be expensive, so does not retain information when power is turned off. So the RAM, whatever we have discussed as the primary memory, it's a volatile memory. So it will not retain information when the power is turned off. That's why we call it as the volatile memory. That's why in addition to the primary memory, we need the secondary storage. So less expensive permanent secondary storage is used when large amount of data and many programs have to be stored. That is particularly for information that is accessed infrequently. So when we don't need, we can store it in the secondary storage. The next is the arithmetic and logic unit. Most computer operations are executed in the arithmetic and logic unit of the processor. So it is used for the arithmetic and logical operations. An arithmetic logic operation such as addition, subtraction, multiplication, division, or comparison of numbers is initiated by bringing the required operands into the processor, where the operation is performed by the ALU. So whenever we want to perform this arithmetic or logical operations, we'll bring the operands into the processor, and the ALU will perform the operation, and the result will be again taken back from the ALU. So when operands are brought into the processor, they are stored in a high-speed storage elements called registers. So here we'll make use of the registers for storing the operands. Each register can store one word of data. So here one word means if it is a 16-bit register, it will store 16 bits of data. Access times to the registers are even shorter than the access times to the cache unit of the processor chip. So these registers, the processor will have a set of registers in order to increase the speed. Then next is the output unit. The output unit is the just the opposite unit of the input unit, that is the counterpart. Its function is to send process result to the outside world. For example, here we take device such as printer. Most printers employ either the photocopying techniques, laser printers, or inkjet streams. So inkjet and laser, these are the two types of printers, and they are able to generate 20 pages, 20 or more pages per minute. That is their printing speed. However, they are mechanical devices, and quite slow compared to the electronic speed of the processor. That's why the once you give the job for printing, you did not processor can perform other operations during that. Then some units such as graphic displays provide both an output function showing text and graphics and an input function through the screen capability. The dual role of such units is the reason for using the single name input output or IO unit in many cases. So graphics displays, they generally provide both an output function as for say text and graphics it will show, as well as it can give input through the touch screen capability. So nowadays these things are common. Touch screen capability, even the laptops, then even the tablets, they are having this facility now. So they are called as the IO unit. Then the last unit is the control unit. The memory, arithmetic and logic and IO unit store the process information and perform input and output operations. The operations of these units must be coordinated in some way. So this is the responsibility of the control unit. So the control unit is effectively the nerve center that sends control signals to other units and senses their status. So it will play the role of coordination. So it will provide timing as well as control. It will send the control signals and get their status, whether they are ready or whether they are busy, and then it will coordinate with the processor. An IO transfer consists of input-output operations are controlled by program instructions that identify the devices involved and information to be transferred. So, control circuits are responsible for generating timing signals that govern the transfer and determine when the given action is to take place. So here, whenever we are performing the input-output operations, at that time we'll make use of program instructions that will identify the devices. So this will be done because each device will have the address. So with the help of address, it will identify the device and the information is to be transferred. So what information is to be transferred? That is again identified by the input of, let's say, devices here. And the control circuits are responsible for generating the timing signals. So if you when you generate the timing signals, then we can perform the read operation or write operation. So that will govern the transfers and determine when action is to take place. So again, some of the handshake signals are also used when we are performing the input output.